Greetings, antique radio enthusiasts. Welcome to another edition of Antique Radio Archaeology. Today we're going to be doing part 2 of the two-part series on the history and restoration of the Lloyd C. Greene concert receiver. Now in part 1 we talked a little bit about Mr. Greene, the history of the radio itself, and we took the radio, broke it down to parts, talked a little bit about how each of those parts were restored. And then I went ahead and started prepping the faceplate for reassembly. Now here in part 2, what we're going to do is we're going to reassemble the radio as if it were a kit radio from back in the 1920s. And once I do that, I'm going to go ahead and test it out and see how it sounds. So we'll begin with getting the contacts for the selector switch installed in the faceplate. Now I'm just installing all the terminal lugs. So here I'm just installing a pass-through for the selector switch. Now the selector switch does have a spring, so I have to get some tension on the spring there in order to get it to work right. The switch itself uses the post as a connection, and I have to ground it to the foil. Now we're installing the tuning capacitor, which is pretty straightforward. So here I'm just mounting the tuning coil using these lugs. The lugs themselves are hooked to the A positive terminal lug and the stop lug on the selector switch. They're not doing anything electrically, they're just anchor points for the coil. Now this is the connection between the antenna and the tuning capacitor. And now I'm just attaching the wire coming from the coil to the other side of the tuning capacitor. And this is the bus bar that's going to go from the tuning capacitor to the grid leak capacitor and resistor. Now I'm replacing the grid leak capacitor and resistor with a different one, so I can only use one anchor point here. There is a screw on the back of the capacitor that allows me to attach it to the coil. So now I'm simply soldering the different windings to the selector lugs. Here I'm re-drilling the holes in the tube socket holder, since this tube socket's a little bit bigger than the one I've replaced. I'm also going to follow up with a threading die to rethread the holes. The screws go directly into the hard rubber. Here I'm simply soldering the filament lug wire to the bus bar there, and it's going to attach to the copper foil on the back of the faceplate. Now it's just a matter of getting some solder on that bus bar to the copper. The grid lug wire to the grid leak. Here I'm attaching the antenna ground to the copper on the back of the faceplate, and I'm also soldering the antenna lug. This is simply the installation of the variometer. Now I'm attaching a wire from the plate lug to the variometer. Here I'm just soldering the A- lug on the copper foil. Now I'm installing the telephone jack to the B positive connection, which is just using bus wire. And now we're going to go ahead and install the rheostat. I have to remove the wipers and everything in order to get the knob to pass through the faceplate. And here's another one of those pass-throughs. Now when installing the wipers on this knob, the one thing that I'm doing is making the pointer point straight up while centering the wiper on the coil itself. So here I'm just installing the connection between the A positive terminal lug and the rheostat. So as you can see, this potentiometer was in really bad shape originally. I've totally restored it, and I replaced the coil and coil form with a 50 ohm coil form. Unfortunately, the radio that I need it for needs 200 ohms or better, and I've not been able to locate a coil form with the 200 ohm resistance. So I'm going to have to make one. Now this is the original coil form that came with the original potentiometer. What I'm going to have to do is rewind it. I'm going to be using what they call nichrome wire. Now nichrome wire is a wire that was patented in 1906 by a man named Albert Marsh. What it was designed to do is create a heating element using resistance. It could also be used as a resistor when coiled around a form and put in a potentiometer. Now the way nichrome wire works, the lower the gauge, the lower the resistance. So I'm going to use the 34 gauge. The 34 gauge is 16.4 ohms per foot. What I'm going to need is about 12.2 feet. And I got that by doing some simple math. Divide the 200 ohms by 16.4 ohms, and I wind up with 12.2 feet. And then I take the 12.2 feet and multiply it by 12 so I can get my inches, and I wind up with 146 inches. And then dividing 146 by the amount for one turn. The one turn is 1 1/4 inch. If I divide that into the 146 inches, I wind up with 116 turns. Now I need it to be 200 ohms or better, so I'm going to go ahead and fill the whole coil form. Unfortunately, this is an uncoated wire, so every turn cannot be touching the next turn, otherwise it'll all short out. So I have to be real careful in making sure there's a gap between the turns. So let's get started. Okay, this is a very tedious process. I started by tying off the one end of the coil wire. I went ahead and pulled out about 12 feet and just started wrapping it. And I took a couple of breaks because I could only wrap for so long, but this whole process took me about 4 hours. So luckily you don't have to sit here for 4 hours watching me do this. But it is very tedious because you have to keep tension on it at all times. Now when I did take my breaks, I would tape it down to hold the tension. So it should have a little more than 200 ohms. 234 ohms. I'll take it. Okay, I'm just removing the 50 ohm coil and replacing it. Very simple. Just gotta disassemble everything and reassemble it. Okay, installation of the potentiometer is pretty much exactly like installing the rheostat. Have a pass-through. again, make sure the wiper is centered on the coil and the indicator knob is pointing straight up when you tighten up the wiper. Now I'm just installing some bus wire. These are the two connections between the potentiometer rheostat, and the other wire that's going down actually hooks to the other side of the filament on the tube. And this bus wire, which still has the capacitor attached to it, attaches down below to the B minus at the top at the phone jack. It also goes to the variometer, and it also attaches to the potentiometer. So here I'm just soldering that B minus connection. And the phone jack connection. I'm just tightening the filament lug there. So I picked up these felt little discs off of eBay. They are really nice because it allows you to put pressure on the knobs so that they hold their position after turning them, and it keeps you from scraping up the front panel. So before ever applying power to a newly restored radio, I always like to go ahead and compare it to the schematic to make sure I have all the connections in the proper places. Starting with my antenna here, I'm going to go ahead and follow this wire down, and I'm going to hit my C1 here, which is right here. The other side of C1 is going to come off here, and it's going to come over and hit the grid capacitor and grid leak right here. Follow that through, and it's going to hit the tube pin right here for grid, which it does. So that part is good. The other side of C1 is tied inside here to a little wire that comes off of this coil, and that starts this part here. 15 turns later, I'm going to hit the first contact on switch 1. 32, 45, 60, and 80 turns all hit their appropriate contacts. Right here, the wiper right here is actually tied to the copper, so I know that part of the circuit's good. So if we come over here to the plate, we're going to hit the variometer. The variometer comes over here, ties to the phone jack. Boom, boom, to the phone jack. The other side of the phone jack is here, comes down, and it hits B positive. My B negative side is going to come back underneath, back up this rail, and it hits the other side of this C2. So that's here. This side of C2 is over here on the phone side. So I know that part of the circuit is good. Now what I have yet to do is I'm coming up here and I'm going to hit this wiper for R3, which is my potentiometer. So I know that's good. That side of the potentiometer is tied to copper right here. That's good. The other side comes back around and down and hits my filament right here. It also comes over to R2, which is my rheostat, which is right here. So I know that part of the circuit is good. Now on the other side of the rheostat, I'm going to come down and I'm going to hit my A positive right here. And my A positive here, my A negative ties to the copper shield, which is right here. So I have my entire filament circuit because that part of the filament has been identified. Now the other side of the filament is the copper. So that is this little wire that I soldered to that brass bus that goes back, and then I've got it soldered to the copper here. So I've had that connection. So I've identified pretty much every connection on here with the exception of my ground. That ground here is the antenna ground, which is tied right here. So that's it. That's all the connections, and having verified that, I'd say this thing's ready to have power applied to it. Okay, we have a good tube. That's awesome. So now comes the moment of truth. I do have a ground hooked to the antenna, an electrical ground. So let's go ahead and get the power hooked up. I'm going to go ahead, and this is the A battery, 6 volts, plus and minus, and now plus. This is the B battery, it's 22.5 volts, minus and plus. And final connection, oh, I do have to hook up the antenna. Here's my ground. Now the ground is tied to the foil, which is tied to all the other grounds. So this one is the actual antenna. And I'm going to go ahead and hook up my headset. Unfortunately, I don't have a speaker hookup because it's not designed for a speaker. It should go through an amplifier. So I'm going to have to tune this while listening on the headsets, and hopefully you guys can hear enough from me doing that. So let's go ahead and get ready to do this. Let's go ahead and center those. Center this. Pop that in there. Okay, I got filament. So what I just did there was use the tube as an on-off switch. By leaving the tube loose, the thing stays off, and when you twist it, it turns the set on. Unfortunately, these older sets don't have on-off switches. Okay, I'm hearing a whistling. I'm hearing some voices. It's very faint though. Don't know if you can hear that. Okay, I've got a couple of different stations. That's what's going on here, and they're kind of fighting with each other. Oh, there we go. go. Loud and clear. Well, thank you for tuning in to yet another episode of Antique Radio Archaeology. This concludes part 2 of the Lloyd C. Greene concert receiver restoration. Now, as you notice, I used the term tune in. Tune in was a phrase that originated in the 1920s by a man who was trying to describe the operation of some radio knobs to make a station appear in the headsets. That man's name was Mr. Lloyd C. Greene. So you can add that to your trivia knowledge. Now, I've given it some thought, and because kit radios typically come in this form and that's all you get, most people had to buy a separate case for them, or they had to build one from, and most people did, from scrap wood that they had laying around. So in the interest of completing this restoration fully, I'm going to go ahead and do a part 3 to this series, in which I'm going to go ahead and build a case from scrap wood that I happen to have laying around, just like somebody in the 1920s might have done. So we're going to go ahead and do that, and as an added bonus, I did get the amplifier that I had with the other Lloyd C. Greene receiver that I have working. So what I'd like to do is go ahead and follow up once it's in its new case with firing it up with the amplifier and a speaker, so you can hear this thing through the amp and speaker like people back in the 1920s might have done so. So happy restorations, everybody. We'll see you next video. Bye.